everyone, I'm Ashok. Welcome to another video on machine learning data science terminologies. And in this video, we're going to look at objective function. Objective function is a very important concept and it's actually a heart of your machine learning optimization. So what is it? Well, optimization function, the objective function is, I'll just write it as OBF. Objective function is, it contains two terms. One is a cost function or a loss function. Other one is your regularization term, reg term or regularization term. Okay. So the goal of any machine learning algorithm, let me take a black color. Any machine learning algorithm, to the goal of ML algos is to minimize your objective function. Minimize your objective function. When you minimize your objective function, you reduce the loss, thereby you are increasing the accuracy, or in simple terms, your algorithm is better fitting to the data given. Okay, so that's objective function. So if you want to explain a little further, let's take a simple algorithm of linear regression. So linear regression is fitting a line to the given data. Let's say you have a data like this, and then you have a line like this which is being fitted, and so obviously we have errors. So error is defined as actual value minus predicted value. So in this case, this is your predicted values and these are your actual values. This is error 1, E1, E2 and E3. In linear regression, the loss function or the cost function is the sum of square of errors. So E is equal to I would say capital E, which is a loss function, is equal to E1 square plus E2 square plus E3 square. If you have 100 records or 1,000 records or 10,000 records, you'll have 10,000 errors being added. So if you want to put it in a mathematical way, error is sum of, y is a line equation. So y is simply mx plus c, or let me put it as w is weight and b is bias. So it's actually wx plus b. Then your error function is a summation of all the errors from the first record to whatever number of records you have into wx plus b minus y. Okay. Oh, okay. So it doesn't matter. So it's a summation of, anyway, taking a square of it, so it doesn't matter. So I'm going to say wx, just a second. Something went wrong with my, okay, good. Wx plus b minus y whole square. Okay, great. So this is your cost function actually. So the goal of your machine learning algorithm, in this case linear regression, is to minimize this. But if you simply minimize this without, so let me just draw it quickly one more time. This is your line, and this is your E1, E2, and E3. Okay, and E, as we defined, it's wx plus b minus y whole square. That's your E. Of course, you sum it up for the entire errors. Okay, so this doesn't give you any control over the algorithm, which means, I mean, if I want to, there might be situations where you have data like this. Okay, so a lot of data is actually here and one record over here. Because of this, your line might actually go this. Because of one outlier, one extreme value, your line is actually drifted towards that, and it doesn't really work well for any of this data. If you want to control this slope, you want to actually control the line, you can add one more term. That's what we call it as a regularization term. Regularization term. So I'm going to add another term, which is actually lambda into, let's say I'll call this alpha, this one, alpha into w, whereas w is slope, still the same, slope or weight. So now I have another term which is alpha. By changing the value of alpha, let's say 0 to, if you put 0, then it is just a simple regression. 0 to 1, or you increase the alpha value, By controlling this alpha value, you can control the slope because it's affecting your W. Okay, essentially the algorithm becomes like this. So you have uh, W into X minus alpha plus B minus Y. So you actually control the W value, so the alpha value, so that you can control the slope of the line equation. So this is actually called as lasso regression. Okay. So you're basically adding one more term. Okay, so the objective function of lasso regression is your cost function, which is just your ordinary least square, adding the square of sum of the square of the errors, plus another term called as alpha into W. We also have, and this is called as L1 regularization because you're only adding, first order of your slope as a regulation term. We also have L2 regularization. It's called as ridge regression, in which you have the same cost function. You have, let's say, lambda into W square, which is a square of your slope. So if you increase your lambda, then the compensation, the penalty is actually an exponential. It's a very highly penalized. This is used in certain purposes. So to come back to our explanation, objective function contains two terms. One is the cost function or the loss function plus a regularization term. The purpose of the regulation term is to avoid overfitting. So thereby you can control the algorithm to fit best to the given data. Okay, that's all it is. Thank you very much for watching this video. If you like this channel, please subscribe and click notification. I'll see you in the next video.